Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 31, an extension. You may not have seen this in class, but this is an additional lesson that is pretty cool. So, system of equations leading to the Pythagorean triples. So here we have a classwork exercise, and it says, identify two Pythagorean triples using the known triple 3, 4, 5. So keep in mind that a Pythagorean triple just simply means that if you have a right triangle and one leg is 3 and the other one leg is 3 and the second leg is 4, then the third leg is 5 because 3 squared is 9, 4 squared is 16, 5 squared is 25. So if we have a squared plus b squared equals c squared, and this is c, and this is b, and this is a, then we get 3 squared plus 4 squared equals 5 squared. So we're reviewing real quick here. And that gives us 9 plus 16 equals 25. And sure enough, 25 equals 25. Okay, so that means that we have a Pythagorean triple. Just simply means that a Pythagorean triple is three numbers that when plugged into the Pythagorean theorem, a squared plus b squared equals c squared, it is true. So it says to identify two Pythagorean triples using the known triple 3, 4, 5 other than 6, 8, 10. Okay, so all we need to do is, if we scale up a triangle, so if I scale this up by a ratio or a scale factor of 2, where r equals 2, remember scale factors? Okay, so there's a lot of review here going on. So if r equals 2, that's our scale factor. And all we have to do with a scale factor is multiply all of the sides by that 2, and 3 times 2 is 6, 4 times 2 is 8, and 10 times 2 is, or I'm sorry, 5 times 2 is 10. So that's a new triple, 6, 8, 10, because 6 squared is 36, 8 squared is 64, and 10 squared is 100, and when I add these up, it is true in the Pythagorean theorem. So all we need to do to find Pythagorean triples is multiply 3, 4, 5 by any number to yield a scale of this triangle that's length sides 3, 4, and 5. Okay, so all I have to do is multiply 3, 4, and 5 by any number other than 2, because they said other than that one. So if I did 10, for instance, and I multiply all of these numbers, I'm going to get 10 times 3, which is 30. I'm going to get 10 times 4, which is 40. And I'm going to get 10 times 5, which is 50. Okay, so 30, 40, 50 is a Pythagorean triple. Okay, I could even take that 3, 4, 5 and multiply it by 7. 7 times 3 is 21, 7 times 4 is 28, 7 times 5 is 35. There is another Pythagorean triple. Okay, now it says identify two Pythagorean triples using the known triple 5, 12, 13. So 5 times 5 is 25, 12 times 12 is 144, and 13 squared is 169. Okay, so 25 plus 144 is 169, and that equals 169. Okay, so 5, 12, 13 satisfies the Pythagorean theorem, so it's a Pythagorean triple. And now we want to identify two of these triples using the known triples. So all we're going to do is use a common ratio, and we're going to multiply 5, 12, 13 by some number. So just to be different, I'll do 3. And I'll put 5, 12, comma, 13 in parentheses like this. 3 times 5 is 15. 3 times 12 is 36. And 3 times 13 is 39. So 15, 36, 39 is a Pythagorean triple. And, I don't know, let's do 5. 5 times 12, and 5 times 13. So 5 times 5 is 25. 5 times 12 is 60. And 5 times 13 is 65. Okay. Okay, so there's two Pythagorean triples. So 25 squared plus 60 squared would equal 65 squared. 15 squared plus 36 squared should equal 39 squared. Okay, so there's two Pythagorean triples using 5, 12, and 13. Okay, now number 3 says identify two triples using either 3, 4, 5 or 5, 12, 13. And you might look and say, well, I already just did that. Why are they asking me in number 3 to do the same thing? But they didn't. They're asking for a Pythagorean triple here. They're asking for a Pythagorean triple here. They're asking for just triples here. Okay, so the difference between just a triple and a Pythagorean triple is Pythagorean triple has to be integers. 15, 36, 39, 25, 60, 65. All these numbers we came up with in the first two are all integers. But if I take 3, 4, and 5 and multiply them by a half, then I'm going to get 1/2 times 3, which equals 3 halves. I'm going to get 1/2 times 4, which is 4 halves, or 2. And I'm going to get 1/2 times 5, which is 5 halves. Okay, so 3 halves, 1.5 squared, 1.5 squared is 2.25, and 2 squared is 4. That adds up to 6.25. And 2.25 squared is 6.25. So this is a triple, but not a Pythagorean triple because it is not integers. Okay, so I'll do one for 5, 12, 13 as well. So if I have these three numbers, I'll just put them in parentheses because I'm going to distribute. And how about we do 3/4 this time? Okay, so 5 times 3 is 15 divided by 4. And the 4 times 12 would cancel and give me 3 times 3, so that's going to just be 9. And then 3 times 13 is 39 over 4. So there's a triple. And if you want me to check, I'll check that with you. Let me get my calculator. Okay, so I'm just going to show you that 15 over 4. So if I put 15 divided by 4 in parentheses and square it, and add that to 9 squared, that's going to give me 95.0625. Now I need to check 39.4 to see if that's the same number, because a squared plus b squared must equal c squared. So if I take 39 divided by 4 and square it, I get 95.0625. How cool is that? And if I hit math, enter, enter, that is 1,521 over 16. Okay, so it checked. All right, so this squared plus that squared does equal that squared. So there's two triples that are not Pythagorean triples. Okay, so now we're going to look at this extension problem here. Let me move this up and get rid of this distraction. Okay, so this says use the system x plus y equals t divided by s, x minus y equals s divided by t, to find Pythagorean triples of the given values s and t, and recall that the solution in the form of c over b comma a over b is the triple a, b, c. Okay, so first of all, you have to understand what they're saying here. So t over s, t has to be greater than, I don't want to use it, okay, I got to write my t's correctly. T has to be greater than s, for starters. T is greater than s. So when I have t over s, it's a number that's greater than 1. If I have s over t, it's a number that is less than 1 but greater than 0. Okay, so x plus y equals the number that's greater than 1. X minus y equals the fraction that is less than 1. So that's for starters. Okay, so before I go any further, I want to explain to you why we have this system here that we're setting up to find Pythagorean triples. And this here is a photo of what they call the Plimpton 322. So it's right here. Columbia University, Plimpton 322. So this is a stone that was found, and it's like 4,000 years old, and these markings on it, it was found in a location that is now considered Iraq, I believe is what it said, and it basically is listing multiple Pythagorean triples, and coming up with really large values. They were used probably in the construction of buildings and so forth, because Pythagorean theorem is used to find lengths of sides. So you have, when you have a perfect square corner, right corner, 90-degree corner. So anyhow, this is the Plimpton 322 is what it's called. And these values, obviously we can't read them. It's not in English, and it's not using Roman numerals or the numbers that we use here. So this is not anything that we can read, but these are values that people have been able to translate and decipher. So that's what this is all based upon. So let me just get this out of the way. And this here. Okay. So we're basing all these values on what they've found on the Plimpton 322 stone. All right. Now, we are given this problem where s equals 4 and t equals 5. So all we're doing is trying to find a Pythagorean triple using this system. So I would start off by saying x plus y equals t over s, which is 5 over 4, and x minus y equals s over t, which is 4 over 5. Okay, so what they're really saying is if we take any number, 4 or 5, we can find a Pythagorean triple by using this formula. Okay, so since we have a system, we've done this in the prior classes, what you're going to do is add or subtract to cancel out one of the variables. And since y's are opposite, we're going to add these two, and x plus x equals 2x. Y plus a negative y is 0, and that equals 5/4 plus 4/5. Well, keep in mind that we cannot add fractions that have the same different denominators. So the least common denominator of 5 and 4 is 20, or the least common multiple. And so I had to multiply 5 by 4 to get 20, so 4 times 4 is 16. And I had to multiply 4 times 5 to get 20, so 5 times 5 is 25. And now I can answer this question, what is 5/4 plus 4/5? Well, it's 25 20ths plus 16 20ths, which is 41 20ths. Okay, so then I'm going to divide both sides by 2. And divide this side by 2. And I'm going to put that over 1 because we have to remember a rule. And we can't divide a fraction by a fraction, but we can multiply by the denominator's reciprocal. Okay, so multiplicative inverse, 41 over 20 times 1/2 now we're going to do. And so x equals 41 over 40. Okay, so we found x, and now we want to find y. So if x plus y equals 5 over 4, I'll use the top one, and now I know x is 41 over 40, plus y equals 5 over 4. Well, 40 and 4, well, this is easy because I need to get my denominators the same, so I'm going to call 5/4 50 40ths by multiplying the top and bottom by 10. And to get y by itself, I'm going to subtract 41 40ths from both sides. And when I do that, I get y equals 50 minus 41, which is 9, and then over 40, 9 40ths. So now I have the points, so now we put them in the order of x comma y. So I have x is 41 over 40, y is 9 over 40, and now I have two fractions, and if we look, now it's in the form of c over b, comma a over b. So now I know my a equals 9. Okay, a is top right. B is my denominators, and they should be the same. So my b is 40. And my c is the top left, 41. Okay, so now I'm going to get my calculator out, and I'm going to take that 9 and square it. And actually, let me clear this. Start over. 9 squared plus, I'm doing the Pythagorean theorem, a squared plus b squared should equal c squared. 9 squared plus 40 squared equals 1,681, and 41 squared should be 1,681, and booyah, we have a Pythagorean triple. They're integers, so I can call it a Pythagorean triple. So they gave us s equals 4, t equals 5, and I found a Pythagorean triple of 9, 40, and 41. And I don't know if this is impressive to you, but I find this really cool. So let's do another one. So now we have s equals 7 and t equals 10. Now you need to rewrite everything because that will help you remember it. So we take x plus y in one equation and x minus y in the other. And the x plus y is t over s, and x minus y is s over t. So when we're adding, we get more than 1. When we're subtracting, we get less than 1. That's the way to remember it. So now I'm going to plug values in, and my s and t are 7 and 10. So I'm going to have x plus y equals t over s, which is 10 over 7. And I'm going to have x minus y equals 7 over 10. So there's my setup. Okay, I'm going to combine these to get rid of the y, so I'm going to add x plus x is 2x, the y's cancel, equals 10 plus, and these denominators are different, so if I want this to be 70, then I have to multiply it by 10, so it's 100 over 70. And if I want 70 in the denominator here, I had to multiply it by 7, so 7 times 7 is 49. Okay, so I'm just changing this. That actually equals that, but I don't want to put an double equal sign. Okay, so now what we're really doing is adding these two, and that is 149 divided by 70. So when I divide by 2, I get x equals 149 over 70 times 1/2, which equals 149 over 140. Okay, so now I found x. Now I plug that into my x plus y. So x is 149 over 140 plus y equals my t over s, which was 10 over 7. Okay, so I know I have to move this 140 over here, so I have to multiply this by 20 over 20. So that's going to equal, I don't want to use the equal signs. So I'll just leave it right like that, and I'm going to rewrite the next line. So I have 149 over 140 plus y equals, and 10 times 20 is 200, and 7 times 20 is 140. So now I have common denominators, and I can subtract 149 over 140, and subtract 149 over 140. And when I do that, I get y equals 200 minus 149 is 51 over 140. I put that in my ordered pair, so my x was 149 over 140, and my y was 51 over 140. So keep in mind, what is A, what's B, and what's C? So if I go back here, look at the formula. This is new, so we got to make sure. It's C over B, comma A over B. How do we remember that? Well, C over B, comma A over B. You could think of it as CAB, reading it from top left and going down to the next line like we're reading lines in a paper. CAB, and then just repeat the B. All right. So my A is 51. My B is the denominator repeated, 140. And my C is the top left numerator, 149. So if I square 51 and I square 140, I will get the square of 149. So that is a Pythagorean triple. Okay, super impressive. Now I'm going to do it one more time. X plus y equals the number greater than 1, that's t over s, or 4 over 1. X minus y is equal to the number that's less than 1, or 1 over 4. So now I have that system, and I need to have a common denominator, so I need to multiply this by 4 over 4 to get the denominator of 4, and I'll rewrite this. X, let me scroll up here. So I'm taking x plus y, I'm just repeating this here, equals 4 times 4, which is 16, over 1 times 4, which is 4. I have a denominator of 4. This one's already a denominator of 4, so I don't need to do anything to that one. And just leave that 1/4. Okay. Whoops, that's not supposed to be a 1. That's a y. What was I thinking? X minus y and x minus y. So when I add these, we're adding. X plus x is 2x. Y plus a negative y is 0. 16 plus 1 is 17. And 4 plus 4, or 4 over 4 is still 4 over 4. I shouldn't say 4 over 4. 16 plus 1 is 17 over 4. Divide by 2. Divide by 2. Remember, it's over 1. And we're multiplying a fraction by a fraction, by the way, so that's like that. So that's canceling, and we get x equals 17 over 4. Flip it and switch it, as we say in class. 1 over 2. So the answer is 17 over 8. So there's my x. So now I take that x and substitute it in here. 17 over 8 plus y equals 4 over 1. I need to multiply this by 8 over 8 to get a common denominator. Rewrite it as 17 over 8 plus y equals 32 over 8. Subtract 17 over 8 from both sides. And when I do that, I get y equals 32 minus 17 is 15 over 8. So now I have the ordered pair. 17 over 8 is x. 15 over 8 is y. Remember my CAB, C, A, B, repeat the B, fill it in, okay, ways to memorize stuff. So my A equals 15. My B is my common denominator, and my C is my numerator on the left. Okay, so I'm going to check this one, just because we didn't check the last one. So it's going to be 15 squared plus 8 squared. And that came out to be 289, and 17 squared is 289. That is ultra cool. Okay, so there we have it. There's 6 and 7. It says, use a calculator to verify that you found a Pythagorean triple in each of the 4 through 6. Show your work below. All right, I'm not going to show any work on that. I think we've covered this enough. I did not check 5, though, and I will. So let's check 5. So a squared, 51 squared, plus b squared, 140 squared. Enter, 22,201, 149 times itself. 22,201. Mind equals blown. Okay, I think that's enough for one lesson. I'm not going to show my work on the calculator thing. So this is the end of lesson 31. Review this super cool lesson summary and go do your problem set.